So now we've got a polynomial function, p of x equal 2x squared plus 9x plus 1. And I want to do a couple of things in our process of polynomial analysis. I'm first given this number, 1/2, and your author of your text, Larson, will call that a C value. And I want to evaluate p of 1/2. Well, you may think, well, okay, that's easy. Just take the 1/2 and plug it in for the x's and calculate p of 1/2. But, you know, working with fractions can get a little risky when you're doing that. So we've learned that synthetic division, using 1/2 as this number in synthetic division, can possibly help us alleviate the problem of all the fractions. So I'm putting my coefficients up here along the top. I'm not missing any terms. I've got my x squared, my x to the first, I've got my constant, so I don't need any zeros here along the top. And whatever I get right here, whatever number I get right here underneath the 1 will actually be the value of p of 1/2. So let's see what that is. I'm bringing down my 2, and then 2 times 1/2 is 1. 1 plus 9 is 10. 10 times 1/2 is 5. 5 plus 1 is 6. So p of 1/2 is 6. Well, what does that tell us? It tells us, well, A, that x equal 1/2 is not a 0 of p of x. But it does actually give us the coordinates of a point on p of x. The point with coordinates 1/2 and 6 is actually on our curve, whatever our curve looks like, which we haven't quite gotten there yet. So you may be asking, well, okay, 1/2 is not a 0, but what is a 0? Well, we also talked about something called the rational zeros theorem, and to find what are even the possible numbers that I could use as my C values to find the rational zeros of p. Okay, so here's where we realize that all of those numbers are going to be fractions. That's what rational numbers are. The numerator of all of those possible zeros will be the factors of 1. Well, the only factors of 1 are 1 in itself as far as integers go. And then the denominator will be factors of your leading coefficient. Okay, that's a 2. The factors of 2 are 1 and 2. And then all positive and negative values of those. So what kind of combinations do we have? We've got 1. We've got 1/2. We've got, that's it, positive and negative. So that's 1, 1/2, let's see. That's 1, that's 1/2, that's -1, and that's -1/2. We've already realized that 1/2 is not a 0, so if we needed to, which we will do later on, we could actually try the 1, the -1, and the -1/2 to see if those are actual zeros of the function. Let's try one more. All right, so let's say that this time our function p of x is x cubed plus 2x squared minus 7. Obviously not a factorable polynomial in our factorable standards. I'm given that c is -2, and I simply want to evaluate p of -2. So I'm taking that c value, and I'm going to use synthetic division using the remainder theorem. So I'm putting the coefficients of p along the top, and I am missing an x term, so I need a 0. And whatever number I get as my remainder will be p of -2. All right, so I'm bringing down 1. 1 times -2 is -2, plus 2 is 0. 0 times -2 is 0. 0 plus 0 is 0. 0 times -2 is 0. 0 plus -7 is -7. So P of negative 2 actually equals negative 7. Make sure my math is right here. Yeah. 0, 0, 0. Yeah. Okay, so what are, again, the possible rational zeros? I mean, you know, the C value was given to me here. But, you know, what if I don't know what to plug in? What if I don't know what numbers to try in my synthetic division? That's the point. You're trying to narrow down your results. My numerator will be all the factors of 7, my constant term, which are 1 and 7. And then the denominator will be factors of my leading coefficient, which is 1, and all positive and negative values. So I've got, let's see, I've got a 1, a negative 1, a 7, and a negative 7. So, okay, so that makes sense why negative 2 didn't give us 0 as a remainder. It wasn't even a possible rational 0. So later on we'll be starting to, you know, work with these numbers in the rational zeros theorem and synthetic division to determine which of those are zeros of the function.